All right, hello everybody, and welcome to another OWASP Toronto chapter meetup. My name is Adam Greenhill, and I'll be your host for this evening. Just to give everybody some time to trickle in, we have a little bit of a pre-show banter with our guests as usual, and we are welcomed today with two different guests. So we have two different presentations. First is Boominda Anushka, who is a senior consultant at Security Compass, a coworker of, at least me, no longer Jack and Ophi, but he has over 8 years of experience in the field and specializing in network, cloud, app, and container security. Also, we have Dr. Baljit Malhotra, an award-winning researcher known for his work in open source and API data management. He was the first to conceptualize the world's first API composition analysis based on source code static analysis. So very interesting people we have today. And yeah, to just kick things off, how do you guys stay up to date with security? It's constantly changing. It's a ever evolving field. You guys Twitter, Reddit, like how do you guys stay up to date?
Yeah, I think using social media is like my main approach now to stay up to date. Previously, I used to follow up newsletters and like I sign up for several newsletters, but right now it's mostly social media because rather than newsletters, I think it just keeps traction of what's happening around the world. So I most rely on social media, LinkedIn, Twitter, those places.
Yeah,
for a while
definitely.
there.
Yeah.
Sorry.
Yeah, same. I guess
Go ahead.
security is a moving target problem, right? So we are always playing a catch-up game. That keeps us active and young, if you think that way. Yeah, absolutely. So personally, I've been looking into this space, specifically focused on open source for almost 15 years or so, and more recently moved towards API security. So really looking forward to Boominda's presentation as well and connecting with the OWASP chapter.
Thank you.
It'll be great. Yeah, I mean those are great ways to stay up to date. I mean, is there anybody that you guys follow on Twitter, or is there any like open source communities that you guys particularly are a part of that you leverage for this?
Yeah, so mostly for like LinkedIn and places, I follow OWASP. So that's the best place to get like web application specific updates. And then you have CNAC. They also like share like very good material on what are new vulnerabilities and like those kind of things. And I also like follow some security researchers that I know of, like, so they also like share their research that they find out. Yeah, that's also like another good way. Yeah, those are places.
Yeah, for me, I started my career tracking a SecList. I think people on this call perhaps know SecList, where just researchers, enthusiasts, they are just dumping their researches. So that's how I started, and I started telling people security is not a security problem. Security is also a data management problem, because a lot of data that was published in those reports, they are very unstructured. People are writing just emails, the certain references, screenshots, and things like that. So a lot of times the problem to solve was to just extract useful information. And of course, I follow very closely NIST. More recently, I've started tracking ISACA and ISSA. These are some of the organizations that are focused on compliance as well. Cloud Security Alliance is primarily focused on cloud security, but there are a lot of commonalities between these organizations. So yeah, if you're not following ISACA, ISSA, or Cloud Security Alliance, apart from OWASP, you should look into them.
Yeah, absolutely. Yeah, when you said SecList, is that like Daniel Mess, like the GitHub project, or is that something else?
I don't know what's the genesis of that, but it's just an email list that people subscribe to. And I don't know who started it, but I'm happy to look into that and provide some resource. I have not looked into SecList for almost like 5 years now.
Oh, okay. Yeah, we just posted it. It's seclist.org. Yeah.
Yeah.
Um,
It's a
all
great
right.
source,
Yeah.
by the way.
Oops. Yeah, I know it is a great list. But yeah, thank you guys for your answers, and I think we're probably good to start the presentation now. But before we begin, a couple of housekeeping notes. If you have any questions or comments, we'll be periodically checking the chat and speaking them to our presenters. If you need CPE credits or you have any feedback for us, you can use the link in the description of this video. And if you're looking for work or you're hiring, also you can discuss that in the chat now as well. Boominda will be our first guest. Are you ready, Boominda?
Yes, I am.
All right, the floor is yours.
Okay. Thanks, Adam. Right. First of all, let me get the presenter right. Okay. Great. Good evening, everybody, and thank you very much for having me here. So today, the topic that I will be discussing about is secret management in containers. So what I will be discussing in here is how you store secrets in containers and various attacks that can be there in containers, and basically how you can uh, secure your secrets that you use with containers. So moving on, if I talk a little bit about me, my name is Boominda Anushka, and I'm working as a senior consultant at Security Compass at the moment. And I'm currently, my work is mostly doing penetration tests of web applications, APIs, infrastructure, network, cloud, and content environments. So I've been in the information security domain for like 8 to 9 years. So I started my career first as an information security analyst, and at the time I did incident response, forensic kind of work, and vulnerability assessment. Then I moved to become a system engineer and implementing security solutions. So working with things like SIEMs, WAF, PKI solutions, DNS, EDR solutions, and those things. Then I gradually moved and to the area of pen testing, and I was an penetration tester since then. And I also like completed my master's, and I have a bunch of certifications. And the reasons that I ones that I did like certification in Kubernetes security and Kubernetes administration. So as of now, I'm mostly focusing on learning about containers and cloud environments. And like if you like you can connect with me in LinkedIn. So I'm in LinkedIn. If you can visit this URL, and feel free to connect with me, and I will be happy to answer your question either regarding this topic or for any other question related to cybersecurity in general. So before I start the presentation, a small disclaimer. So the opinions that I express in this presentation are my own, and I do not express the views and opinions of my employer. So with that in mind, yeah, so the agenda for today's session is we will be first looking at what is secret management in containers, what this topic means. And then we will be moving on to understand some concepts that we need to know in order to understand how containers work and how secret management works in general before talking about secret management in containers. Then we will be looking at secret management concepts and how you can manage secrets in content orchestration solutions and on third-party secret management solutions like HashiCorp Vault. And then we will be moving to discuss about how you can attack secrets. And finally, we will be ending the presentation after discussing about how you secure secrets. Uh, so moving on, let's first see what is secret management in containers and what this topic is about. So to talk about secret management in containers, we should first understand what a container is. Uh, so if you look at the definition that Docker provides, which is an popular container runtime environment, a container is a standard unit of software that package up code and all its dependencies so that the applications run quickly and reliably from one computing environment to another. Now, let's see what actually this is. So I have taken in here two images that shows difference between containers and virtual machines. I guess like most of us know what a virtual machine is. And how virtual machines run is that you have the infrastructure layer, and top of that you have hypervisor. And on top of hypervisor, you can run several virtual machines which has its own guest operating system. But when it comes to containers, what happens is that you have the infrastructure layer and the host operating system. And on top of the host operating system, you have something called as a container runtime environment running. So one popular container runtime environment that you might have heard is Docker. So you have something like Docker running on top of operating system, which is actually a service on top of operating system. And on top of this container runtime, you may have multiple containers running. So if you compare these two different approaches, you will see that the containers will not have the burden of a guest operating system. So because of that, containers are like extremely lightweight, and they run very quickly and reliably from one computing environment to another. So that means like you can move containers from one host to another host very quickly and easily, and it will run there with like minimal configuration, and it will be deployed really fast. So it's really convenient to work with containers. So let's see what the secret is. And for this one also, I took the definition that was there from Docker. So as for Docker, a secret is a blob of data such as a password, SSH private key, SSL certificate, or another piece of data that should not be transmitted over a network or stored unencrypted in a Docker file or in the application source code. So if we look at this definition, like basically a secret means anything that should be kept secure. So if you have any sensitive data that should be kept secure, that we can consider that as a secret. Uh, so if you have a secret that should not be transmitted over the wire in an unencrypted manner, and it should also be not be stored in a data store or in the hard disk drive in an unencrypted way. So what this Docker file is and how you should not store secrets in Docker files in an unencrypted manner is something that we are going to discuss later in the session. So we'll be discussing about this thing in later in after a couple of slides. Now we discuss what a secret is and what a container is. So let's see what secret management in containers is. So secret management in containers means it's the art of securely storing, accessing, and distributing secrets to containers throughout the container lifecycle. So important thing that we have to remember in here is the container lifecycle. So the secret should be secure throughout the lifecycle of a container. That means when you are building a container image, you should make sure that the secrets are not stored in the image and it should be secure. And when you are starting up a container and if you are loading a secret to a container, that process should be done in a secure manner. And when you are running a container, and if it consumes many secrets, and if you need to modify these secrets later on, you should modify these secrets so that in a safer manner. So throughout the container lifecycle, from its start to finish, we should make sure that the secrets are managed securely. So this concept is called as secret management in containers. So you can to do secret management, you can use different content orchestration platforms, or you can either use third-party secret management solutions. So for example, if you have a content orchestration platform like Kubernetes, you can use Kubernetes to securely store secrets. And if you have a third-party secret management solution like HashiCorp Vault or something, you can use these to store secrets. So we'll be looking at these things in details later in our presentation. So now we can deep dive into some concepts that we should know to understand security, like how to keep your secrets secure in a container. But before that, do we have any questions in this section? Okay, I guess no. Right. Okay, so now the first concept that we are going to dig into is container image. So a container image is something which is lightweight and a standalone executable. So this container image include all the things that you need to run the container. So for example, it contain information about what the code is, what the application code that you should have in your container. And it has information about the runtime that you should use when running this container. And it may also have information like what are the dependencies and libraries that you should use when running this container. Uh, so usually this container image, we specify it by using something called a Docker file. So this Docker file is a text document that contain like all the commands that that the user should call in this image, and all the commands and the structure of this container, and how it should be loaded and how it should be run on a container runtime environment. So this Docker file is the kind of like it details all of this information. Now, to run this container image, like we need to store it somewhere. So container registry is the place where you store container images. So container registry is responsible for like storing and distributing container images. And these registries, they can be either private or public. So if you have like played with Docker or any of the container runtimes, you have probably used some of the public container registries when you are using them. So one popular example is Docker Hub. So this is one free to run container registry. And apart from that, there are like many other container registries as well. And you can also have a private container registry for your organization if you prefer, that only store the images that are approved by your organization. So container registry is basically the place that store and distribute container images. Now we talk about images and where they are stored, but where these are being run. So these are run in a place called as container runtime. So container runtime is the software that is responsible for running the containers. So popular container runtimes include software like Docker, Containerd, CRIO, and there are many other container runtimes. So this container runtime, it makes sure that the content is loaded, it has the proper resources that it need to run, and is running smoothly. And let's say that okay, you can easily manage a container runtime that's running on one host, which has maybe like 5 or 6 containers. But what if you have like multiple container runtimes, which are running on different machines, which has hundreds of containers running? So this is where the concept of container orchestration comes in. So container orchestration is the process of automating deployment, scaling, and management of containers application. Which this means is that if you need to manage containers that are running multiple container runtimes, you can use a container orchestration platform. So it will manage all these container runtimes and make sure that the containers that you are running as per your expected parameters. So some popular container orchestration solutions are things like Kubernetes, Docker Swarm, and OpenShift. And in this session, we will be mainly looking at Kubernetes and how you can use Kubernetes orchestration platform to secure container secrets. So moving on, let's see how all of these things fit together. So you have container runtime, which is responsible for running a container. So on top of a container runtime, you can have one or more containers. And you may have multiple container runtimes running on different hosts. So to manage these all container runtimes, you can have a container orchestration platform, something like Kubernetes. And then you can have a container registry, uh, which actually stores the images that you need to run these containers. So container runtime, what it do is that it fetch the image from the container registry and run the container. So when the container runtime is under the container orchestration platform take care of fetching the image which is stored in a container registry and loading it in a container runtime that it manage. So this is in a very rough manner how containers work and how container runtime, containers, container orchestration platform, images, and registries fit together. Okay, with all that background information, I think we are good to move to the next section, which is how you can manage secrets. But before that, I would like to see whether we have any questions on the chat. Okay.
Yeah. Oh, sorry. Yeah, we just
Yeah.
have one question from Pravin. As far as I understand, containers are used for deploying the code. Do you think containers configuration details will be exposed in production environment?
Uh, yeah. So container configuration details can be stored in like if you have something like an orchestration platform, you can store the container configuration detail on the orchestration platform. So for example, containers, we should only configure it so that like in a very generic way. So for example, let's take something like an Nginx container. So if you have an Nginx server running, and then you should only fetch the Nginx image from the container registry and load it in your container runtime. And the configuration that this Nginx server uses, you can define it in the container orchestration platform. Uh, so for example, if you're using something like Kubernetes, you can specify something called a config map, which contain the configuration of this container instance, and you can load that configuration to the container when it's being run. So to answer that question, if you use these tools properly, then you don't need to expose the configuration of a container in the container image itself. You can simply use things like config map to like load the containers when the containers are being run. So you can keep the container and its configuration separate. Hope I answered that question properly. If not, yeah, feel free to ask any follow-up questions. And are there any more questions?
Doesn't look like it, Boominda. I think you're good to continue.
Okay, cool. Yeah. Okay, so let's see how we can manage secrets in containers. Okay, so the first thing that we like to look at here is how the secrets are managed in container images. So the takeaway in here is that you should never ever store a secret in a Docker file. Now, if you ask me why is that, let's take a look at an sample example. So so this is a sample Docker like a file that I wrote. So in here, what this Docker file do is that it will take an container image called Alpine image, and then it sets an environment variable on this container image, which is actually an database URL which contain the PostgreSQL connection parameters like username, passwords, and its IP address and the port number. And then it will run bunch of like it may run bunch of other tasks that it need to run in order to like do its work. So if you have a container like this, and if you run this container in your like container runtime, then what will happen is that when you run this container in your container runtime, that container will have this environment variable set, which contains the username and the password of your PostgreSQL server. But the thing is that this container image which contain this Docker file, this will be stored in a repository. So if this repository is public, this Docker file can be read by anyone who has access to this container repository. So anyone that read this Docker file will be able to extract your username and password of the PostgreSQL database. So that's why we say that the container images should never ever store secrets, because like anyone who accesses the container repository can simply get the container image, get the Docker file out of that, and read this sensitive information that is stored in the Docker file. So the key takeaway in here is you should not store secrets in container images. So how do you store secrets, and how do you make sure that your containers can access secrets? You can do this by using something like an container orchestration solution. So for example, Kubernetes. So you can use your orchestration platform to set the secret when you run the container. So let's see how you can do this. So for example, like I mentioned, you can use something like Kubernetes to load the secret to the containers. Uh, so you can do this in three main ways. The first way is that you can load the secret as a file in a volume mounted into your container, or you can mount it, yes, or you can load the secret to the container as an environment variable. Or there is a third option where you use something called Cubectl, and you use a secret with the Cubectl when you need to pull images from a container registry to a pod. So during this session, we will only be talking about these first two concepts. So the third concept is kind of like an very niche scenario where you don't usually use in your day-to-day life. So because of that, and to limit the scope of this session, I only limited how we discussed to these two concepts. So let's say that now you need to specify a secret in a Kubernetes environment. How you can do that is by you can use this tool called as Cubectl, which can be used to manage Kubernetes clusters, and you can use Cubectl to create secrets, either list secrets that are there in your cluster, or to get certain information of a secret. Uh, so let's say that you created the secret in your Kubernetes cluster using Cubectl create secret command, and this secret has a name nginx hd password. So let's see how you load this secret to a pod. I told that you can load this secret to a container either as a volume or an environment variable. Uh, Now I have been using the terms container and pod interchangeably. So if you might have confused what these two are. So in Kubernetes, a pod means one or pod means something like an one or more containers, nothing more than that. So pod is a certain term that is used in Kubernetes to define, uh, like refer to one or more containers that are run in a Kubernetes cluster. So if you look at this container, like the pod configuration in here, this configuration is written in a format called as a YAML file. So YAML file is, so you need to instruct the Kubernetes cluster on how the containers configuration should be. And the YAML is one format that you can use to inform the cluster about the container configuration format. So if you look at this file, you can see that there is a container running which has a name nginx, and it used the image nginx, and it used the port container port 80 out of this container, and it has a volume mount, and the name of this volume mount is hd password volume, and it is mounted on etc nginx conf folder. And if you look at the volume name, it represents the secret that we created earlier, which is the nginx hd password secret. So what will happen in here is that the value that we stored in this secret will be loaded as a file under this mount part, and the pod can consume this secret from here. So another method that you can use to load the secret to a pod is as an environment variable. So to do that, you can simply use the environment specification and define a name for this environment variable, and define like what should be the name of this environment variable and what should be the value of this environment variable. You can use the previously created secret that we created in the earlier to like specify and refer it in here. So there are like two methods in here: loading as a volume or loading as an environment variable. So if you look at what is the most secure way to load the secret, the most secure way, as for the hardening guidelines such as CS benchmark, is loading a secret as a volume. So why is it? If you ask, the reason is that when you load the secret as a volume, let's say that you want to change this secret. And if you want to change this secret, as soon as you update your secret in the Kubernetes cluster, and if your secret is loaded as a volume, this change will be propagated to all the containers that consume this secret. But if you load your secret as an environment variable, and if you change the secret in the Kubernetes cluster, that change will not be propagated. So the only way to update the pod is either by stopping the pod and restarting it. So when you do that, only the container will start with the new secret that you configured. Because of that, usually it's recommended to run like load secrets to as an volume rather than as an environment variable. Okay, moving on. Now let's see how Kubernetes stores secrets. So Kubernetes stores secrets as basically for encoded strings in a binary file which is stored in etcd. So etcd is like the data store of Kubernetes. So it's Kubernetes store all the information, data, metadata about pods, all the information in this etcd database. So by default, this etcd database is in this location. Now, when I was describing this, if you're like security conscious, you might have blinked when you heard that the secrets are stored in basis for encoded. Because basis for encoded is that it's encoded. Like you can easily reverse and encode an encoded string, and like you can get this decoded value easily. And this is not encryption. So you don't need the key or any secret that only you know to read this value. So this is same as kind of in terms of security, this is same as storing the value in plain text. Uh, so there are some methods available in Kubernetes to encrypt these secrets, but it's not enabled by default. So to view this secret, you can use this kubectl get secret command, and you can give the secret object name and ask Kubernetes to put the output of this in YAML format. So when you do that, you can view the secrets that are configured on the Kubernetes cluster. So if you look at here, you should be able to see that the secret that has been stored in here, and this is the name of the secret, and this is the value of the secret. So this is a basis for encoded string, and if you decode this from your CLI, you should be able to get the value in clear text format. Okay, so to interact with etcd database, there's a tool called as an etcd-ctl that you can use. So if you use this etcd-ctl tool, you need to know like what's the etcd endpoint that you are running, and you need to know the certs used by the endpoint and the keys that are used by the etcd server and all those information to query the etcd database and get a value. So for example, if you need to get a cert, get the value of nginx HT password secret that we created earlier out of the etcd database using the etcd-ctl tool, the command would look like this and the output as this. But I told you that this is simply stored as basis for encoded strings in the etcd database. And etcd database is a binary file. So you can simply run a tool like strings in this binary file and extract all the secrets and strings that are stored in the etcd database. So for example, if you run strings on the etcd database, and if you grab for the string opaque and the lines, 4 lines before that, you should be able to see all the secrets that are stored in opaque format in the etcd database like this. Similarly, you can like query any type of secrets that's stored in etcd database if you have access to etcd database backup. Now let's see how you can encrypt this etcd database. So to encrypt this, we have to use something called as an encryption configuration. So this is an sample encryption configuration that you can use to encrypt an etcd database. So this uses a CBC encryption mode, and you can specify your key that you use to encrypt this etcd database as basis for encoded format. And this encryption of secrets is done by a component called as Kube API server in the Kubernetes environments. And to update the Kube API server with this encryption configuration, you have to modify this manifest file of this Kube API server and add this encryption provider configuration option to this manifest file. And after you do this, and if you create any new secrets, these secrets will be encrypted. So if you use the HCDCTL tool and query the secret, query a value of an encrypted secret, you will see that it returns as an encrypted string. So you can't easily like decode it and read it like in the previous case. Okay, so yes, it's good that you have the option to encrypt the HCD database, but there are certain considerations that you should ensure before you enable encryption on the HCD database. So the first thing is that you should make sure that your encryption configuration YAML file is secure, because this stores the encryption key that is used to encrypt data in your HCD storage. And another important thing is that if you have created any secrets before enabling this encryption, these will not be encrypted. So these secrets will be stored in plain text format, and only the secrets that you create after enabling encryption will be encrypted. So if you want to encrypt the previous secrets as well, you will simply have to delete these secrets and create them anew. And encrypting HCD, it will not prevent someone who has access to secrets from obtaining them in plain text. So for example, if you can use Cubectl tool, and if you can query the CD database and get information about secrets, you will be able to read the values stored in these secrets and you'll be able to get them in basic for encoded format, which you can later on decode to get the plain text value. Okay, so that's all about how you encrypt secrets in Kubernetes. So let's see how you encrypt secrets in EKS clusters. So if you don't know what EKS is an managed Kubernetes service. So this is a managed Kubernetes service provided by AWS. There are similar services provided by both Azure and Google Cloud, which you can also use. But in here, I will be only talking about EKS for the time being. So if you want to enable secret encryption in an EKS cluster, what you can do is that you can access the EKS cluster configuration in the AWS console, and when you access there, you should see an option as secret encryption. So to enable secret encryption in the EKS cluster, you have to use something called as an KMS key. So KMS is key management service, is another AWS service which you can use to create and store keys for encryption purposes in the AWS cloud account that you have. So simply you will have to load the KMS key in here, which you have in your KMS service, and then the EKS console will use that key to encrypt the HCD database storage. But one thing that you have to be careful when enabling this configuration is that this configuration, after you enable this configuration, you can't disable it. So simply, once you enable encryption, you can't disable encryption as of now. So this is something to keep in mind before enabling secret encryption. Okay, so we talk about how secret can be encrypted and managed in Kubernetes and on EKS. And let's see how you can manage secrets in HashiCorp Vault, which is a third-party secret management solution. So if you are running secret HashiCorp Vault with Kubernetes, then Kubernetes uses something called as a mutating admission webhook to ingest secret into pods. So this mutating admission webhook is something like this. When you when you load the pod configuration or a container configuration to Kubernetes cluster, before this container is being run, it will go through something called as an admission webhooks. So these admission webhooks will change the configuration of the pod that you initially defined. So HashiCorp Vault has a similar admission webhook, which will change the configuration of the pod that you define, and it will inject init and sidecar containers to the configuration of your pod. So the init container that it will inject, it runs before your main app containers in the pod are being run, and it will make sure that the secret is loaded to the container. And the sidecar containers it uses, it will make sure it will run alongside with the app containers, and it will make sure that the secret that is loaded is up to date. So whenever you change your secret, the sidecar container will change the secret that is being used by your pod. Okay, uh, let's see what you can see and what actually happens inside inside Kubernetes cluster when you use HashiCorp Vault. So when you set up HashiCorp Vault in your Kubernetes cluster, you will have at least two pods running, called Vault 0 and Vault Agent Injector. And depending on the configuration of your HashiCorp Vault instance, there may be many more pods running, but at least these two pods should be there. So out of these pods, Vault 0 is responsible for storing secrets and other configuration data. And Vault Agent Injector is responsible for injecting the secrets to the pod. So it's the one that take care of like changing the pod configuration and injecting init containers, sidecar containers as for the criteria that we define. So the criteria that we define on how to load the secret to a pod is what we call as an annotation criteria. So we will be looking at what this annotation criteria is in the next slide. So one thing that we need to keep in mind is that even though we talk about all these Vault 0 voltage and injector init containers, sidecar containers, as a developer or an administrator, you don't usually have to worry about these things because all of these things happen transparent to the developer or the administrator. You only have to like specify the annotations in your pod configuration, and your pod will be changed accordingly by HashiCorp Vault transparent to you. So if you look at the pod deployment at the pod configuration, so this is a sample set of annotations that you can use to inject a secret and use it in a container. So the first annotation is on agent inject. So this is what simply enables the agent injection or enables secret consumption in the pod. And then you have another parameter called agent inject status. So this instruct the Kubernetes mutating admission controller to make sure that the secrets are being updated when the secret is rotated. So your sidecar container will be properly updated. And then you specify what's the Kubernetes role that has the permissions to consume the secrets that you're going to use. And then you specify the part of the secret that you're going to consume in here, which is stored in your Vault database. And then you tell in what format this secret should be loaded. So for example, in here, I'm trying to load the secret as a PostgreSQL database connection string. So when you run this pod configuration, all the injection of init containers, sidecar containers, that will be handled for you by the HashiCorp Vault. So you can see this changes that are being done to your pods by running a command like kubectl get pods with the name of the pod and asking to output the configuration of that pod in YAML format. So when you do that, you should be able to see the volumes being mounted, which has information about which has the secrets that it loaded from HashiCorp Vault, and information about the sidecar container that has been injected to the pod configuration, and information about the init container that has been injected. So all of these things we didn't define in our initial pod configuration, which is in here. It's a very simple configuration which only tell you, okay, run this number of replicas and this number of containers in my environment. So all of this configuration of init containers and sidecar containers has been handled and injected transparently to the developer. So how secret management happen in HashiCorp Vault can be little confusing to understand initially. So if that's the case, you can look at this URL, which has a very good tutorial and provides you with a playground to learn HashiCorp and to learn all these concepts. So I have included it in here in case if you're interested, you can follow this and learn about this. next topic we are going to discuss is on how you can attack secrets. But before that, do you have any questions so far?
I think we did have questions, but I believe you answered them in your presentation. So yeah, I think we're good to continue.
Okay, great. Thanks, Sam. Okay, so let's see some attacks against secrets. So the one attack that you can do is that, let's say that your application that's running on the container, it has something like an LFI vulnerability, which is a local file inclusion. So local file inclusion, when you have a vulnerability like this, what happens is that simply attacker can read the files in your file system. So if that's the case, and if you have secrets mounted to your pod as volumes, you can try to read the values of these secrets that are mounted to the container. So to do this, you can check the value of this file proc mounts, and it will simply show you like what are the volumes that are mounted to the container. And if you see any secrets, so for example, secrets are logged as temporary file system values, and in that case you can visit that part and try to read the secret which is stored in there. And in another case, let's say that you are doing a penetration test, and you identified and you get hands on to an HCD database backup. And if this database backup, if it does not store secrets in a secure manner, like in an encrypted way, you can simply run a tool like strings and get the values of secrets in plain text. So in here, this is the same example that I provided earlier. So I'm querying the database to grab values which has the secret formats of opaque. And if I want, I can also query for the secrets that are stored as service account tokens in the same way. So in here, I'm simply asking for the strings that were there 4 lines before the word opaque, and then I should be able to get some secrets which are stored as opaque password. And if I run a command like that, which look for the string service account token and get the lines before and after that line, and then in that case it will return the values of secret of service account token. So you can query different type of secrets like by using a tool like strings and by using simple grep commands if you get your hands to HCD database backup. So let's say that you have like the best case scenario. You have remote code execution privileges in your container. So the app that is running on the container has an vulnerability, and it has an remote code execution vulnerability, and you can run any commands that you want. And if that's the case, you can simply run a command like env and try to see whether there are any environment variables loaded, or you can simply cat the proc mouse folder and see whether there are any secrets loaded, and if so, what are the values of these secrets, and try to access those things. And another interesting that you can do when you have remote code execution privileges is trying to move beyond beyond the secrets that are already loaded into your container. So for example, let's say that you have RCE into a container, and that container has a service account token mounted onto that. So by default, Kubernetes mount a service account token to the containers if you haven't disabled it specifically. So when this happens, this service account token can be used to interact with the Kubernetes cluster, and this token will be stored in by default in this particular location. And if that's the case, what you can do is that you can download the kubectl tool, and then you can pass this token to the kubectl tool, and then you can find the CA cert that is used by the Kubernetes in this location. You can also pass it in here, and then simply you can query the Kubernetes service source and the Kubernetes service port to get information about the Kubernetes cluster. So if that's the case, to see what are the permissions that are associated with the service account token, you can run something like kubectl auth can I list. So then it will list all the permissions that you have in the Kubernetes cluster. And if you have access to like Kubernetes secrets or get information about the secrets, in that case, you can use kubectl to get information about other secrets that are stored in the Kubernetes cluster. So for example, let's say that you have full access to secrets. In that case, you can get all other service account tokens and try to find an administrator level Kubernetes service account token and try to escalate your privileges even. So this is a classic example of abusing misconfigured role-based access control. You can make sure that the service account tokens will only have limited access and the access that they absolutely need to do their work uh, when they when you create a service account. So unless you have this configured properly, someone might be able to abuse this misconfigured RBAC uh, role-based access control permissions if they get remote code execution privileges to a container that you have. Yeah, so we talked about some potential attack scenarios, and next, the last stage of the presentation, I will be talking about how you can secure secrets. But before that, do we have any other questions, Adam?
Nothing that I see here. Let me just check the more up to date. Nope. Yeah, I think you're good.
Okay, great. Okay, so let's see about some general best practices that we can do to secure secrets. So the first thing that we can do is encrypting secret storage. So you can secure secrets that are stored in the HCD using an encryption configuration. So how you can use the encryption configuration and encrypt it, we discussed a little bit earlier in this slide set. So you can use something like an encryption configuration and encrypt the secret storage. And then you can consider like configuring RBAC to limit access to secrets. So you can configure things like roles, cluster roles, role bindings, cluster role bindings to limit access to these secrets. So the important thing in here is that to make sure that the service account and the users in the Kubernetes cluster only has access to what they need to access. So you should only grant access on a needed basis as for the least privilege principle. So that's another best practice that you can use. And another thing that you can do is to make sure that to detect like any potential compromises is to audit access to secrets. So let's say that you are seeing something like a pod trying to access a secret which it normally does not access. If that's the case, this may probably indicate a compromise because pods are usually like a static configuration, and they are like when you consider things like pods containers that are running on them, you don't go and like administrators usually don't log into the containers and change its configuration. So if it's accessing a certain set of secrets, usually it will always access the same set of secrets. And the time that this change, either because a container has been maybe updated to access a new set of secrets, or maybe it's compromised. So if it's not updated, and if it's trying to access secrets that it should normally access, then probably this may indicate a compromise. So if you have any alerts configured to indicate these kind of things, then that's another best practice that you can use to limit potential impact of a compromise. And if you look at both Kubernetes and third-party secret management solutions like HashiCorp Vault, both offer capabilities that we can use to monitor access to the secrets and audit this access. Okay, so some other concepts that we can use are things like using secure design patterns. So one design pattern that we can use is that we should make sure that we should minimize the service account tokens used in the pods. So whenever possible, we should not load the service account token to a pod. And this should only be loaded if it's absolutely required. So there are also other design patterns that you can use even if a service account token is required. Uh, so you can do something like this. So let's say that you have an app container running which needs to access some Kubernetes services, and therefore it will need a service account token. So rather than loading the token in the service in the like the app container, consider running a different sidecar container which has this service account token loaded. And maybe you can have something like an volume share between the sidecar container and that container, and you can update the content which is there on the volume using this sidecar container. So in that case, even if the app content is compromised, then the service account token will be on the sidecar container, and it would be very hard for an attacker to obtain this token which is stored in a sidecar container. Another design pattern that you can use is using stateless and immutable containers. So stateless means the persistent data of the container is stored outside of the container. You can do this simply by using volume mounts. So if you have any persistent data that you need to store, you can mount a volume to a container and store this data in a volume. And you can keep the container file system as read-only. So if you have the container size file system as read-only, that means the container is immutable. So which means that the container will not be modified during its life cycle. So if you specify the container file system as read-only and make it immutable, and use volumes to store stateless data, in case of a compromise, the things that an attacker can do will be very limited. And to bypass these protections, it will take a lot of time, which can grant you more time to detect these kind of attacks. And you can also consider designing containers providing minimal access to secrets. So this is where threat modeling comes in to the picture. So when you are threat modeling an application, you can identify, okay, what are the microservices that should be front-end facing and the back-end facing, and what microservices store and process sensitive data, and what microservices should have access to sensitive data such as secrets. After you identify those sensitive data and secrets and the microservices that you need, you can consider running these sensitive workloads in individual containers. So in an ideal scenario, it would be best if you run one microservice in one container, but this is not practical and this can be a management nightmare. But you can approach this in a threat modeling approach, and you can consider, okay, what are the containers that should be separated, and what containers has the how can I break these containers so that access to the secret is minimal, and how can I break this container setup so that my important microservices which process sensitive data is properly secured. So you can design your containers in such a way if you know what are the actual microservices that need processing of these secret informations. Yeah. So the next concept that we can use to secure secrets is using dynamic secrets. So to understand dynamic secrets, first we need to understand what a static secret is. So a static secret is something like a password. So you create a password to log into your account, and this password may be static until the point that you change it. So dynamic secrets are different than that. These are generated on the fly when you need to use them, and they will only they will get expired quickly, and you will have to request a new secret whenever you need to use it the next time. So even if a dynamic secret is compromised, it will only be valid for a very short time. So Kubernetes does not support using dynamic secrets, and we will have to rely third-party secret management solutions like HashiCorp Vault to implement dynamic secrets. Yeah. So another concept that comes with dynamic secrets is secret rotation and expiration. So secret rotation, Kubernetes support secret rotation for service account tokens. So for example, if you specify a service account token, you can set an expiration seconds, and when this token gets expired, Kubernetes will automatically change the token and modify the containers that consume this. Uh, However, you can't do this for like general secrets. But let's say that you have a certain secret that you need to modify in the Kubernetes cluster. If you manually modify the secret, of course, that change will be propagated as long as the secret is loaded as an volume in the containers. So if you use something like HashiCorp Vault, it supports secret rotation and expiration both. So by default, HashiCorp Vault revoke credentials after 768 hours, or when you use Vault list revoke command. Uh, of course, these values are default, and you should like configure these based on your threat profile and uh, based on the threat profile of your application. Yeah. So when you implement these best practices, I think it should be helpful for you to like secure your secrets that are running on your system. With that, we have come to the end of our presentation. Any questions?
Yeah, Boominda, I've got one while we wait
Sure.
for people to answer their own or enter their own question. So if I have like, I don't know, like 1,000 containers, how can I determine if there is any secrets in them? Is there like a scanning tool or like a part of the DevOps pipeline I could leverage? Like how would I do that?
Yeah. So as far as I know, just to query like what are the secret stores in like something like 1,000 uh, containers, there is no like a specific tool that you can use, but you can write a very simple script using kubectl and like grep commands. So for example, like I have done this in the past in some of my penetration testing engagements. So usually what I do here is that I use the kubectl get pods command and get the output of all the pods in all namespaces in YAML format, and I prep the secret like so when you store a secret in a pod, it has certain keywords. So I grep for these keywords and get the values that are associated with those things and try to sort and find the unique values. So it's not like a very scalable approach, but it's one way you can use to like identify secrets that are used by the bots that have that you have running on your environment.
Okay, so kind of extrapolating from there, then, if an organization is using, Kubernetes or Docker containers or really any kind of container within their CI/CD pipeline, they could develop like some kind of static analysis tool to look for these things, not just secrets, but other things too, to identify potential vulnerabilities.
Can you repeat the question, please?
Oh no, there was no question. I was just saying that, like what I've seen is that organizations will in their CI/CD pipeline, have some static analysis of the container
Yeah,
configuration files.
yeah.
Yeah. I mean, is there any other kind of areas that you would recommend people with Docker containers look at, like aside from just secrets management? Is there any other common misconfigurations that you see?
Yeah, exactly. So common misconfiguration that we see based on like RBAC configuration and the network segmentation of containers, and like how the containers like properly always how they are segmented. So in lot of cases, what we see is that there are no any network policies defined to like secure containers that are running. For example, in that case, it's like you have given someone access to your entire internal network at one place. So by default, one container running in a Kubernetes cluster can talk with any other container, which is in the same namespace. So unless you specifically deny that traffic, that allow all traffic will be accepted. So what we have seen is that most of the time this network policies that you can use to limit this traffic is not being implemented. So that's one part that you can use to secure containers. And apart from that, like the RBAC configuration. So RBAC is another major factor that usually lacks. So like this is also common for like all other cases, not only Kubernetes or containers. Uh, so unless you define your like role-based access control policies for your service accounts and all other users that use your container environments properly, that would kind of give like unintended access, and which would ultimately lead to compromise containers and people using compromised containers to laterally move throughout your container environment and to escalate in their privileges. So these are like the two major things I think that should be looked at apart from secret management in containers.
Okay. And just from the chat, Magno mentions that Git secrets and Hadolint are great tools to do some static analysis on Docker containers. They also ask, are there any tools or do you have any tips to configure RBAC correctly?
Yeah, so there was a tool called as I can remember, Rekas or Rakas or something, REKKAS. I can probably share the link with you guys like in the chat a little bit later. So you can use that tool to like audit the RBAC configuration. So that's this one tool that come to my mind. Apart from that, if you have any service account token, you can use kubectl auth command with cani subcommand, and you can list the permissions attached to a certain service account. So as I can remember, the format is something like kubectl auth cani dash dash list, and then you can specify dash dash as, and you can specify as what user you should list the commands. So you can use these these commands to like list the RBAC configuration and to see who has access to what. Yeah. Oh, and to add another thing to that, your previous question, like how can someone query secrets that are used by the pods? So they can like they can't see the secrets used by the pods by using this command, but they can simply run kubectl get secrets dash dash all namespaces, and they can list all the secrets that are used by all the namespaces, and that might give an idea about like what are the type of secrets that are stored, and then they can see okay what secret is loaded in the what pod into what pod. So that's another way that you can look at it.
Okay, that's great to see. We just posted in the chat the reference that you mentioned.
Okay.
Awesome. Is there any other questions that you have for Boominda? And while we wait for that, what about like container breakouts? Is that like a common issue, or is that more of like a 0-day exploit? Like, is that common, or what's the
Yeah.
story there?
Yeah, it's a very like interesting question. Okay, so yeah, I was like looking at some container breakouts in us, and container breakouts depend on the container runtime and the underlying operating system that you are using, and what is the configuration that you have on this container runtime and the operating system. Uh, so, for example, if you run a container with certain capabilities, like access to the file system and access to the network. So, depending on the capabilities that a container has, there are some vectors that you can use to break out from the container and access the host file system. And if you look at something like Windows Server containers, so you might know that Windows also allowed you to run containers in Windows operating system. So Windows Server containers by default does not specify security boundaries like in a hard manner. So that means basically any Windows Server container, like if you run container D on top of Windows Server and have Windows Server containers running, then basically you can break out of any Windows Server container to the Windows Server OS. So because this is a problem because Windows Server containers does not define hard security boundaries. So this is a certain limitation defined by Microsoft itself. So this is a OS kind of limitation. So the recommended approach in here is using Hyper-V backed Windows Server containers. So likewise, like there are various factors that you can use to do container bypass, like container breakouts. It can be either the container capabilities or the OS configuration or the runtime issues, uh, like these things.
So it's like a fundamental issue with containers then.
Yeah, exactly. So it's all depend on how in the environment that you choose, how you configure it, and how you secure it.
All right. Oh, sorry. We have one additional question here. Also, that's good to know from a container breakout perspective. But Ibro says, can SecComp and AppArmor help out with protecting secrets? And if they can, how?
Okay, so for protecting secrets, I don't think it can like exactly help, but I talk about like making the containers immutable and like hardening the containers. So they can probably like both SecComp and AppArmor, they can help with hardening the containers. So they will make sure that so you can like implement certain restrictions on the containers. So for example, something like a container breakout, or even if someone compromise a container, what they can do, what file systems that they can access. So it will limit the actions that the container can take. But it will, as far as I know, it will not limit what an attacker can view in terms of secrets that are loaded to the container. So that limitation is there with using SecComp and AppArmor because the focus of SecComp and AppArmor is little bit different than the focus of securing secrets. So yeah, so AppArmor and SecComp, those are used to like harden the containers, so it would be hard to break out from the containers, and even someone compromise them, it would be hard to like do any further actions from the compromised container.
Okay. Ibro, does that answer your question? We'll just wait for him to respond. But additionally, we have another question from Bitwise here. Also, hey
Ah,
Bitwise, how's it going?
hey, man.
He asks, how do I stay current and up to date with or when it comes to container security?
Yeah, good question. So one thing that I usually follow is that you can always follow like if you want to like look at vulnerabilities that affect content runtimes, then Synac is like a best source that you can follow. And also like you can sign up for like get directly information from both popular content runtime environments like Docker and Kubernetes. You can sign up for their resources and newsletters, and you can get information from them. Apart from that, like yeah, so those are like the sources that you can use to stay updated directly on containers. But apart from that, I guess like even the like generic like or like any other source that discuss about security, cybersecurity matters can also be used. But if you only talk about container specifically, then I think the newsletters from like content orchestration platforms like Docker, HashiCorp, New Kubernetes, uh, those places, and Synac would be like the ideal places.
All right, that's good to know. And to kind of close things off, Ibro also wanted to bring up, can Falco rules help or yeah, he just wonders if Falco rules can help.
Yeah, as I can remember, Falco is used for auditing. Correct me if I'm wrong. Yeah, as I remember, Falco is used for the auditing. So you can use Falco rules to like configure auditing. Uh, but yeah, so in terms of auditing, it can be done. But apart from that, like securing secrets, I don't think like it will do much rather than like auditing access to the secrets, if my memory serves me right. I
Okay,
can,
yeah,
yeah.
that's fair. Bitwise also says that he really liked the presentation and wanted to thank you for that.
Thanks,
All
Adam.
right, I think we've reached the end of our time here with Boominda. But if anybody else has any questions or concerns, they can always reach out to him. Boominda, I don't know if you want to drop your email, your LinkedIn in the chat so they can reach out to you. But
Yeah,
but
yeah,
yeah,
exactly.
Boominda, thanks very much for your presentation, and we look forward to hosting you again sometime.
Thank you, Adam. Thanks for having me here and looking forward to the next
Thanks,
session.
Boominda.
Thanks, Sophie.
Yeah. All right. So we have another presentation coming up, but we'll give everybody a 10-minute break between now and that when that new presentation will start. So we will start again at 7:46. So see you everybody in 10 minutes.
See you guys.
All right, welcome back, everybody. Baljit, are you good to go?
Yes, I am. Can you hear me fine, Adam?
Yep, I can hear you fine. And yeah, so thank you for coming. And the floor is yours, Baljit. Best of luck.
Thank you so much, Adam, and the rest of the OWASP Toronto chapter organizers. Really glad to be part of this community. My name is Baljit. I'm the founder and CEO of Tej Lab. Here is a quick introduction about myself. Before starting Tej Lab back in 2017 timeframe, I headed the R&D division of Black Duck Software, which was a market leader in open source risk management. It was a quite handsome successful for us after Synopsys acquisition. Before that, I was a research director at SAP and looking after part of the team that looked after open source risk management across SAP products and services. Been with software engineering roles multiple times, and my last stint was as a research scientist at a university. My specialization is looking into data science, data management related problems. And in this particular case, for the last 15 years or so, I've been applying those technologies and the thought process to solving cybersecurity problems. This is the agenda for the meeting. Just to give you a heads up, my internet connection is not stable. I'm traveling up north in Canada. I'm actually in Whitehorse today. So if there is a connectivity issue, my sincere apologies in advance. But looks like so far it is working well, but please do send me a text message if, Adam, you feel that the connectivity is not good. So this is the agenda. I will talk about the basics of a zero trust model and how to adopt such a model in a API ecosystem at large enterprises. Although the zero trust model is relatively new, and people have looked beyond their different parameters for security reasons, but this seems to be converging where a lot of enterprises have shown interest in adopting this model. Now, this is a general framework and not necessarily applied to only API ecosystems. This is an overarching model you can imagine, which spans across your enterprise ecosystems, not just API ecosystems. Nonetheless, I found this very interesting, and today what we'll be sharing is how we can architect API security to adopt zero trust model to protect APIs. At the end, I would like to keep some Q&A. In particular, if you have any questions, feel free to type in the chat window. Adam and my colleague Tanveer, they are monitoring chat. Both of you, please feel free to interrupt me if there are any important questions during the presentation. So let me go with the very basics of zero trust. Since this is a new topic, I am assuming a lot of participants from the audience will be interested in knowing exactly what this model is about. Now, I'm not going to talk about who proposed it, where exactly it is, and what's the state of the art right now. I'm just going to go into the basic tenets of the zero trust model. Now, the very first principle of zero trust model tells us that every data source or every software service in your enterprise or otherwise, you must treat them as a resource. And all those resources, regardless of which part of the network you're talking about, they must be secured. And access to those resources must be sessional. Of course, we are talking about machine-to-machine communication. That's where the APIs play a major role. But nonetheless, zero trust model asks us to have sessional approach to all the accesses that are granted to different processes or people that are accessing your resources. The fourth principle of this model is all policies that are accessing those resources must be dynamic. For instance, just because I'm the head of a business unit, I have a particular resource access, which I often access from my office, or a bunch of systems that are registered to access those resources. But suddenly I move my place, I travel. These policies must be dynamic. They must be adjusted. Simply because I'm the head of the business unit does not necessarily allow me grant to access those resources. These policies must evolve in space and time, and also the rules that are enforced by the enterprises. When it comes to the integrity and security of your resources, you must monitor them, first of all. And of course, the authentication and authorization, you are perhaps not surprised, is the actual one of the core principles of zero trust model. I mean, you guys are the champions of this OWASP top 10 API security framework. I don't need to teach you what authentication authorization are, but it is a core principle of this model. And I'll talk actually not briefly, but I'll talk quite a bit about this authorization and authentication problems in the context of API security. Now, it is not just a one-time process. You must collect as much useful information as possible to actually regularly uh, uh, evaluate the security posture of your resources, and must enforce those revisit these policies to enforce the changes that you need to adopt to constantly monitor them, or regularly monitor them. Now, of course, we are living in the world where GDPR, privacy, all those concerns are there, but this is one of the core tenets of this model, that we must collect data and across different resources that are being used regularly. I've already talked about some of these examples, but I'm going through this very briefly one by one. So please feel free to stop me at any point in time if you need more clarification. If you want to read more about this zero trust model, I have listed 2 resources that are really good starting point for you if you have not looked into this already. There is a really good paper by Stu and his colleagues, Scott, Oliver, and it is available online from NIST's website. I have listed here the link. This basically talks about architecting a zero trust model. It's just a caution that they are not necessarily talking about only API security there. It's a zero trust model, so they're talking about enterprise-wide cybersecurity model. But nonetheless, this is very useful, and most of my investigation was driven by this paper. And also, in some places, they have talked about what are the challenges with these APIs as part of the zero trust model. They touched upon that topic, but did not necessarily go into detail because of the scope of that paper. Cloud Security Alliance, another very well reputed and respected organization, they have come up with their own set of working models. There is a group which is led by Jason, Janine, Bob, and Unita. They have published some of the resources related to zero trust model. So if you have not looked into this model, this will be a good starting point for the audience. Now let me go into the details of how this zero trust view looks like from an API ecosystem perspective. Now, any enterprise API ecosystem may consist of multiple systems. You may have a set of APIs that are built by your internal teams, being consumed internally for your products and services. But you may be a digital company that is actually providing APIs as products. A lot of companies have started to treat their APIs as products because there is economy involved in it. Think of every API call as a meter that you can bill to your customers and partners. So a lot of APIs could be built for monetization purposes as well. So they are being exposed to your external customers and partners. Furthermore, you may have your own internal teams, processes, and tools that are actually part of this ecosystem. So let me quickly go through this one by one. You may have software analysis tools. When Boominda was presenting, we talked about scanning tools that can discover certain secrets across your container deployments. There are tools like Black Duck or Veracode or White Source, which looked into open source risk management problems. And then, of course, there are vulnerability scanning tools as well. So you may have this ecosystem of software analysis tools that are part of your ecosystem where your APIs are being developed, checked in, checked out, and this system is always evolving. You may have network tools, you may have security processes in place. Maybe you have a policy that every API that is being checked out or exposed must go through OWASP top 10 tests, or CIS top 20, or maybe PCI compliance tests. So you may have various security workbench and assessment tools in place. On top of that, you may have CXO requirements where you need to expose certain analytics to the CXO level, CTO, CIO level, where they want to see an overview of your API ecosystem. On top of that, you may have an API team that is responsible for the ownership of this API. You may have engineering team that is responsible for maintaining the gateway and exposing or publishing these APIs. You may have a service mesh solution, which is essentially looking into how your APIs are being consumed internally within your organization. These could be free APIs, this could be paid APIs. You may have marketplaces where you are publishing those APIs, or you may have external facing marketplaces where your customers and partners are coming to check which APIs are there and they can try and test and all that. The point I'm trying to make here is your API ecosystem. Any enterprise, large or small, could have a very complex API ecosystem. And implementing your zero trust model in such a complex ecosystem is not necessarily easy. This difficulty can be assessed from a simple fact that 83% of the internet traffic is through APIs now. Now, in theory, you can imagine every organization is going through this digital transformation, where in theory, if 83% is globally, then in theory, on average, everybody has 83% traffic through their APIs. Now, more or less, this could be very different across different organizations, but the point here is more and more APIs are being published, more and more APIs are being consumed internally, and this ecosystem is evolving. We did our own assessment very recently. We looked into different API ecosystems, and we also looked into how many APIs are publicly available that developers can download a GitHub library from, available publicly, and integrate certain API services and whatnot. So this ecosystem within enterprises is evolving faster than you can imagine. Here is actually a live quick snapshot of one of the enterprises ecosystem we looked at. Each dot on this picture actually represents a API server that is hosted where these API calls are going back and forth. Now you can imagine how many vendors are there, what kind of APIs are there, what data they are exchanging, and are they hosted on servers that are vulnerable? Forget about the design of your API itself, which needs to be secure and protected. I'm just talking about third-party APIs that you might be consuming. So this ecosystem can easily go into thousands and perhaps hundreds and thousands moving forward. I have seen cases in which one single product had 5,000 different API integrations. So where do we go from here? If you looked at the 7 tenets I talked about, it is it is conceivable for us to actually map those zero trust tenants to actually the API model as well. Let me go through this one by one. When you look at your APIs, they are nothing but your digital resources, which means that they must be communicated in a secured way, either your northward traffic or southward traffic. All these APIs must be accessed through session. Now, of course, I don't need to teach you OAuth framework. A lot of authentication happens, but this may not be possible in all situations, especially when you're talking about making an API call for hundreds of times. You may not be able to enforce such a policy, but nonetheless, that is what the requirement is, and there could be certain trade-offs. If you look at the policies around API usage, of course, the topmost policy that you want to have is who you want to authorize them, you want to authenticate them, what resources a user is getting, who's accessing those resources, and all these policies are dynamic. You cannot simply assume that you have just an API key, you are using that key forever. You have to look for either deprecating those keys regularly just to make sure that your keys are not compromised and whatnot. And once again, the fifth principle of that model is you must monitor the security posture of APIs regularly. It is not just that you designed an API today, you did all the best you could, by vetting it, but you need to constantly monitor them because the underlying data may evolve, your JSON response may break, your business rules may change. A lot of things could happen. So because of those reasons, you want to monitor the security posture of APIs regularly. Now, if you had one API, perhaps 10 APIs, or even 100 APIs, you can monitor them, you can track them on Excel sheet, you can regularly run test cases. But what if you have thousands of APIs across your different products and services? That manual approach is not scalable. So you need automation intelligence to monitor the security posture of APIs at a very large scale for a very large enterprise. Now, API authentication and authorization, as I mentioned, is a very, very important principle of this model. And OWASP, framework, the top two API specific vulnerabilities as identified by this group is authentication and authorization problems. Authorization has two levels. One is object level, one is function level. So I'll go into those in a bit more detail later. And also, you must collect this information regularly, which is possible for you to do it. So I've already talked about enforcing policies, monitoring them, and also collecting information. So when I say collecting information, do you need to only collect the metadata? Should you collect the payloads? Should you also collect the responses? All these questions you must answer. And whatever helps you to protect your APIs, or if these are third-party APIs that you're consuming, whatever it takes for you to assess them and also monitor them constantly, simply because if it's an API by a very trusted vendor like Microsoft or Google, you cannot just take things for granted because things can fall apart with their APIs as well. So you must collect information as much as you can to constantly monitor your APIs. So you see that in my summary, it is conceivable to apply these tenets of zero trust model to your APIs simply because you need to treat your APIs as products or resources. Now, why pay attention to API security? Once again, as I mentioned, the importance of digital transformation is summed up with one single number, which is 83% of the internet traffic is through APIs. Now, these are some of the recent security breaches have occurred. You can see some big names like Facebook, VMware, and some other not so famous companies. But you will see these attacks happening across multiple vendors, different types of products, and whatnot. As a matter of fact, Gartner has predicted that 80-90% of the attack surface will move towards this of web applications will move attacking through APIs. Now, as I mentioned, the rest of the presentation is digging deeper inside authentication issues with APIs and authorization issues with APIs. But before I go there, let me take a quick pause here and check with Adam if there are any questions at this stage.
Let me just check the other chat. Nope, no questions at the moment. Thanks.
Okay, great. Thank you, Adam. Now, here is a real snapshot of one of the test cases that were performed on one specific API. You will see the important point here to highlight is look at the API 1 and API 5, which is the broken authentication. The first one is the object level authorization problem, and the other one is function level authorization problem. The second is the authentication problem. And if you look at the numbers, 545 and 343, so what these numbers mean is the amounts of or the number of attacks that are happening through these two use cases on these different APIs. By the way, this result is based on the NVD data set. So we looked across, I believe, we looked across different vulnerabilities that were reported in NVD, and we nailed down onto specific API-specific problems, and from there we drew these numbers. The average score was above 7 for these problems. But look at the numbers, how many attacks or problems occurred because of the broken authorization and broken authentication problems. Now let me go to some real examples that I can share with you. Of course, I have removed some of the private information to protect this particular vendor. So this particular API that we detected was actually leaking, people's name, their credit card information, even their passwords, and it is just mind-boggling. And this is just the tip of the iceberg. We, as a company, we are tracking these APIs at a global scale by different vendors and whatnot. And of course, as a responsible community member, oftentimes we go back to vendor and report this, and not necessarily report on public forums just to protect, the interest of these companies. But these are just one of the many examples that we are seeing where some APIs are being compromised. Another problem, and this is again related to object level broken authorization problem, where we could simply iterate this endpoint by iterating this number. Now, in many cases, this is not necessarily the best practice when you design your API. So this you can think of as an API level 1 problem, where we are seeing the API design has a problem in itself, where we can simply iterate this endpoint by supplying just random IDs. So in this particular case, these were just incremental numbers, for example, 1 to 1 million and whatnot, and simply we iterated this number to get all this information about different individuals, their email addresses, their names, their contact information, and whatnot. So what are we talking about? So I tried to portray that API authentication, although may seem to be a very simple to understand, but this is a widely spread problem across different APIs that we see. Now, not every API we are able to test that is available on the internet, but what we have learned so far is, and the investigation we did using NVD data is, this very much confirms our intuition. This is a widely spread problem. And it is a very simple problem. There are APIs without any authorization, or sorry, any authentication. No API keys, no user ID passwords, no tokens, and whatnot. And that's not necessarily good practice. And in some cases, there are weak keys that are being used. You can simply rotate them. They are never deprecated. In some cases, you can easily guess some of these API keys. Some of the other problems are API keys being passed in the URLs. So we have seen cases as part of the URL parameter, you could supply either API key or user ID or even password sometimes. And the worst situation is sometimes they are not even using HTTPS; they are on HTTP. But I would argue that those are very small group of individuals who do not necessarily have enough security background and do not necessarily understand the implications of those. But when there are millions of APIs, and perhaps moving forward billions of such APIs, automatically detecting all these problems, advising your teams how they are consuming, how these APIs are being consumed internally if they are not built by you being a security expert. This is where automation and intelligence would help us. Now, going along with this list, password, sometimes they are hard coded. They are default, they are weak. Just plainly hard-coded in source codes that we scan, or the libraries that enable these APIs. Sometimes authentications, if you do not have rate limits on your authentications, how many times one person or a user can try accessing to your resource. If it is unlimited, they can simply keep on trying different variations of your key or user ID password to get to the resources. In many cases, even if you're using sophisticated frameworks like JWT, the tokens that are being generated may be broken, or the tools that you're using may be broken. So in summary, there are various use cases why authentication problems are occurring, but there could be other edge cases that are not necessarily listed here. So what are the best practices that we can adopt to essentially to solve the authentication problem and hence meet one of the tenets of the zero trust model when it comes to our API ecosystem? So rule number one, check always authentication mechanisms for all your APIs. Do not take things for granted. Either these are your internal APIs, these are your external APIs. As I will show in a minute, one of the problems we found is sometimes these are internal APIs for testing purposes, for various other reasons. And suddenly somebody checks out this as a pet project on GitHub, and this API is exposed. So various problems could happen. Now, people could say this does not necessarily mean that you have an attack which is imminent, but an attacker can simply grab these pieces of information to find your internal, how you are writing your internal URLs, how it is, what kind of nomenclature you're using for your APIs, and that's where they can start to build a more sophisticated attack onto your enterprise system. Once again, use standard authentication techniques. If possible, use multi-factor authentication techniques. In some cases, it may not be possible always to use a short-lived access token, but in many cases it is possible, especially if this is machine-to-machine API integration, then it may be not avoidable, where you have to have a long-lived access tokens, but again, you do the best you can. Now, in many cases, not many cases, I would say a lot of vendors that we investigated when we looked across different industries, we found that oftentimes you have one API key that is accessing multiple products across your different services that you are providing. This is not necessarily good practice. Maybe you want to have a registration process for each of your applications, and each of those applications have its own authentication mechanism. Now, this is important because if one of your application where your data is not sensitive, but again, By accessing that application, you might be able to get certain pieces of information which you can apply to other application attacks scenarios where you could get to a more harmful data sets or access to those data sets. We often forget how important the rate limit is for authentication. I'm not talking about rate limiting your APIs for the purpose of monetization. For example, let's say 100,000 APIs for $10 or something like that. There could be different policies. I'm talking about authentication rate limits. So how many times you allow? Oftentimes we see this in applications, but for the APIs we could possibly forget this to apply this model. But again, this is a very critical uh, uh, best practice that we should adopt when it comes to rate limiting your authentication process. Now, some of the authorization problems that I'm going to touch upon, you may be familiar with. I've already given some examples where you have one API in which you have given access to an authenticated user, but suddenly this user gets access to another information or ID by simply replacing the ID as part of the URL. For example, this generic scenario, uh, I was authenticated to access API/shop financial info, as a resource, but I replaced simply shop1 to shop2. The situation could be worse if instead of characters, these are simply or numerical numbers, where I can simply iterate to access those different IDs to get to the resources. And it's very easy to understand, but again, a lot of problems we see are very simple, yet widely spread across different APIs that we investigated. This is a real world example we found for this Wallbox API, in which the user is authenticated, as you can see from the top part, which is the put command, where you are authenticated to access a particular machine ID. This is basically a electrical vehicle company or something related to that. Now, by simply replacing those IDs, you could get access to the information of other vehicle drivers and whatnot. And again, this is a not a good situation. For the function level problems, we have seen cases where you have an API that you were authenticated to access certain resources, but suddenly, by changing the nomenclature of that URL, or by guessing, you are able to guess you are able to get access to some of the administrative functions. For example, in this case, I can simply replace users with admins and get access to all the different users in the system. And this is, if I can go back to the example that I showed here, that problem is something similar to this, where we were able to actually access to the entire data set, perhaps in the order of hundreds of thousands of different users. So again, function level authorization problem is a widely spread problem, and again, also, as we see in the investigation we did on NVD data, a lot of vulnerabilities are related to this particular problem. So what do we do? What best practices we can adopt to solve such problems? The point number one here is implement all your authorization checks with user policies and hierarchies. And as required by zero tenant model, these policies are always dynamic. These accesses to these resources are always sessional. And once again, no resource is given access without authentication and authorization. So, and again, don't rely upon the IDs that are reported by clients. Rather, you use these as stored in the session objects. Check authorization for each client request, especially if these are giving privileges to access your admin-related resources. This is a must check. Again, try to avoid using IDs. Not just avoid, but you should simply not use IDs, even if these are random numerical values. You should use UUIDs wherever possible, wherever you can, which are hard to predict or nearly impossible to break. Or at least if you have a rate limit on your authorization, then this becomes difficult to break. Again, the list could be longer than this, but again, these are some of the best practices you can adopt to make sure that your APIs are protected from a security posture perspective. Now, this presentation was, I would say, at the very high level. I did not necessarily mean to go very deep. But I think the audience is technically savvy. I think the special to those two cases, authentication, authorization, you know what I'm talking about. The purpose of this presentation was to map the zero trust model to the API security model. And as you saw, it is very much applicable when it comes to managing the security posture of your API ecosystem. And a lot of organizations, they are adopting zero trust model, and you as a security expert should be able to make such recommendations within your organizations or wherever your role requires you to make be part of such discussion. In terms of principles, they are very easy to understand, but not necessarily they are always applicable in all scenarios. But once again, very basic 7 principles, but again, adopting them into API ecosystem may not always be possible. But a lot of enterprises are adopting this model, and this will be very much part of their equation to when it comes to protecting their APIs. Since APIs have evolved to become very important, any zero trust model that you implement, which does not include API as part of your design and implementation, your zero trust model is likely to fall apart. So please do consider API as part of your zero trust model. And a lot of enterprises, as I mentioned, are already moving into this direction. So for them, protecting the APIs will be very, very important for these enterprises that we deal with. A lot of organizations that we talk to, they are not at a stage where they have figured out everything, but again, they have taken some steps to adopt zero trust model when it comes to API security. Last but not the least, every API you design or you build or use, either you have internally built or you are consuming built by others, you must look into the best practices. You must look into how these are being authorized, authenticated, what data goes in, what data comes out, constantly monitoring them, enforcing policies, either from access perspective or control perspective, and auditing them where they are being deployed, as I showed on a map that I presented in early slides. Where they are being deployed, and collecting analytics, reporting them on a constant basis is what will ensure that your zero trust model implementation is successful with API ecosystem. Now, a little bit about TeageLab. TeageLab is an API risk management company. If you're interested to know more about us, I encourage you to go check the website. And also, Tanveer will be happy to speak with you of a complimentary service that we are providing if you're interested in assessing or having a risk assessment of your APIs in your organization, or just learning about it. So you can either go to website or feel free to go to apidiscovery.com, which is our community platform where you can join the community, learn about these topics, and also play with those APIs, security workbench, and a lot of other tools that are part of the platform. This is my contact information. I know I breezed through the presentation quite fast. I wanted to be respectful of your time. I know this was a long session, including the first presentation. So I wanted to, make sure that you go back for your dinner or sleep or wherever you are. I still have some few more hours of work left. So with that note, I would like to thank you to us, to OWASP Toronto chapter for inviting us. Feel free to contact us or contact your organizers if you have any questions. And with that note, back to you, Adam. If there are any questions, more than happy to answer, or if not, then feel free to share my contact, which is on the slide.
Yeah, thanks a lot, Baljit. Are there any questions or comments for him? And while we wait for the chat to catch up, I don't have a question for you, but more of a comment, I guess. I think coming into this presentation, I assumed that zero trust was more of a technology, like kind of like a cryptographic implementation, for lack of better words. But after your presentation, it seems like zero trust is more of a philosophy, or as you put it, a model. So that's kind of surprising to me.
Yeah, it is indeed a model. It is indeed a set of principles. How do you implement those principles is different to different organizations. And one tool, by the way, may not solve all your problems. So you may have multiple processes, multiple tools to implement your zero trust model.
Right, exactly. Because at the end of the day, it's really just all about implementing like the fundamental authorization controls that have been around for forever, right?
Correct. And if I can go back to the slide, So if I can, these are the principles, original principles of zero trust model. And the next slide, this was where I applied it onto the API ecosystem. And as you said, Adam, correctly, many of these, not many, but in particular one, which is authorization, authentication, security community knows it very well, in and out. And that's why this is very, very important part of zero trust model. But there are other things, for example, how you treat your resources, how they need to be protected at all times, how do you collect information. Every organization can implement these processes or can have different implementations.
Interesting. Yeah, that's really good to know.
And Adam, if I can extrapolate this, could this be true for a larger OWASP community that, or it could be just your personal experience that you thought this was a technology rather than set of principles?
Oh no, this is this is definitely my own ignorance. Yeah, no, the rest of the OWASP community is definitely probably more versed in this. Like we probably have resources on our site that discuss zero trust and talk about it. But yeah, no, I haven't really looked into it. So I learned a lot from this presentation personally.
Yeah, I'm glad. Although I'm glad that I touched upon the basic principles because, at least you found it interesting. I hope that the other audience members, they have found it interesting as well.
Yeah, I'm just looking this
Any other
up
questions,
now.
Adam?
Oh, sorry. It doesn't look like there's any questions right now. But I don't know if Ophi, if you're here, or Jack, if you guys know if there's any like OWASP specific resources on this, because it might be a new domain, like it might be a new area to look into.
Yeah, I think OWASP doesn't, like, there's a bunch of different presentations, but if you're asking about like cheat sheets or like other types of things, I don't think there's anything there. I think they're mostly like incorporating the principles that, that Baljeet talks about here into the existing like resources.
Yeah, I see that as well. I don't see anything specific to zero trust. Sorry, Baljit.
No, that's all right. That's absolutely fine. I'm glad that this raises awareness. And in many cases, this could be very much applicable to a lot of the security professionals.
Yeah, for sure. It definitely has been and still is a hot topic. So I appreciate your insight into it. Okay.
All right. If there are no other questions, I'll bring it back to the contact slide. Feel free to reach out to us or to OWASP organizers for any follow-up questions.
Awesome. Yeah, thank you for that, Baljeet. And thanks again, Boominda. Both of your presentations were awesome and learned a lot. And thank you, everybody, for coming to watch our presentations. You have their contact information, and feel free to reach out to them for any more questions. And thank you to our sponsors. And just a quick reminder that everybody should leave feedback, or if you're looking for CPE credits, just hit that feedback form in the description. Thanks again to all of our speakers.
Adam and Stanway, before you sign out, while we have Baljeet on the line, Baljeet, is it okay for the OWASP team to make your presentation available for the community?
Yeah, that's fine. Yeah, that is fine.
Yeah, we normally have no issues, but I just want to check with Baljeet, Adam. So yeah, he's good to go. So feel free to share that, upload it, and make it available.
Perfect. Thank you so much.
Thanks again.
Thank you very much.
Thank you so much, Adam, and the rest of the colleagues at OWASP chapter. Looking forward to the future sessions.
Thank you.
Thank you.
Thank you, everyone.
We'll be in touch.
Thanks.
All right. Take care. Stay safe.
Thanks, and bye.
Yeah. Take care, everybody, and we'll see you next month.
Have a good night.